So 2014, the entire FRQ is what we're looking at. We're not going to answer every single question, in detail. We're just going to look at them and, think about what kind of questions come up if we're looking at all 7 questions, right? So question 1, I think you might have seen this before. So you're given an experimental data, okay? So usually one of the long questions has to do with a lab of sorts. You might have done the lab or not, you might have done something similar, but the data is so that even if you didn't conduct the lab at all, you can make sense of it, right? So in this one, it says a student is given the task of determining the I- content of the tablet that's in Ki, and a tablet is dissolved in 50 milliliter of water, and there's excess 0.2 molar lead nitrate, and you have a yellow precipitate. They dry it, they wash it, and so on, and so you have the precipitate right there, right? And it gives you data, it gives you information, okay? Now, the balanced equation for this, since the precipitate is a yellow precipitate, that's your lead iodide. Because all your nitrates are soluble, right? Most of your iodides are soluble except for mercury, lead, and silver. So the yellow precipitate is your lead iodide. And you see the equation, it says the net ionic, you have lead plus 2 iodine gives you iodide, lead iodide. Make sure it's balanced. Make sure you write the charges when you write a net ionic equation. And when it says net ionic, do not include the nitrate, right? Because the nitrate is not needed, okay? Explain why the reaction is best represented by a net ionic equation. So then here, what is it asking you? It's just asking you for, well, tell me why you're using the lead and the iodide to give you the solid. Then you can say it's a precipitate. You can say the other ions are the same before and after. So you can talk about spectator ions. Again, that's a point. So what is the purpose of drying and weighing the filter paper 3 times? Why would we do that 3 times instead of just once? To make sure that there's no water, right? Because then if you have water, that's going to interfere with your data. And that's pretty much what that says, right? The filter paper and precipitate must be dried to ensure that all the water has been driven off. That's a point, right? So writing one sentence like that gets you a point. In the filtrate solution, is K plus greater than or equal to nitrate? What do you think? So if you have potassium compared to nitrate, potassium is a lot less because the nitrate comes from that lead nitrate where you have 2 moles per 1 mole, right? And it's added in excess. Okay, again, that's a point. Yeah, and it's added in excess. So you have a lot more nitrate than potassium. Now, how would you calculate the number of moles of precipitate that's produced in the experiment? What would you do? How would you? What numbers? No, this is not quick math. This is where you have a calculator. Come on, John. Work with me. So what would you do? How would you find the moles of precipitate that's produced in this experiment? Okay, so you would find the actual mass from the data. Right? So mass of thoroughly dried filter paper and the mass of filter paper plus the precipitate after the 3rd drying. So the difference between those 2 numbers, right, gives me grams. And then I can convert it to moles. Okay, you were. So again, that gives you a point. Now, that 5.12 times 10 to the negative 4 is moles of lead iodide. If I want just iodide, what do I need? 95%. You don't need a percentage. If I have PbI2, for every 1 mole of lead, I have 2 moles of iodine. So what do? You just multiply it by 2. Okay? So that's just to find the moles.
Wait, why would multiplying it by 2?
Because it's PbI2. So when I'm looking for moles of ions, I need to see what the molar ratio of the ions are to each other. Pb is 1, right? I2 is 2. So when I have, let's say, 10 moles of PbI2, that means I have 10 moles of PB, 20 moles of iodide.
If they're both 2, would you only multiply by 1 or would you multiply by 2? Like if there's PB2, I2, would you multiply it by 2?
You would still multiply by 2. Yeah. Because it's twice that, the amount that you have. Okay, so then the question is really asking you for percent, right? And you get the moles, you get your mass, and the mass that you started with in the Ki tablet so that you can see how much iodine is in that Ki tablet. Okay? And up to that point, what was it, like 6 points or so? Yeah.
We need to stop.
Okay? Now, it says in another trial, so the student did this again, and instead of using 50 mils of water, they used 55. So now, would the mass percentage be more, less, or the same if you're using more water?
The percentage would be the same because you're drawing out, right?
Right. So the percentage exactly will be the same because the lead is added in excess to make sure there's no iodine left over. So your iodine is not going to change. See, you got this, Jonah. Uh-huh. All right. Now, here is also an equilibrium question at the same time. So they added some equilibrium here as well. It says a student in another lab wants to determine the iodide content of Ki, but doesn't have access to lead nitrate. So they don't have lead nitrate. However, the student does have access to silver nitrate, which reacts with iodine and still precipitates out, and the value for the KSP for AGI, though, is 8.5 times 10 to the negative 17. Okay, so that's a pretty small KSP, right? Will the substitution of silver nitrate instead of the lead nitrate still result in precipitation of this iodine? Yes or no?
Yes.
Why? Because it says justify your answer. And you don't get points unless you justify it. Even though it has a tiny KSP, what makes the iodine still precipitate out?
Oh, because it's soluble.
Because it's still insoluble,
Yeah, it's
right?
soluble.
Plus, you're adding silver nitrate in excess. So
Oh, yeah.
you're adding enough, right, to make sure that it does precipitate out.
Wait, is it still in that? Oh, yeah, because you have to do math. Do we have to do math?
You don't have to do math.
How do we know it's still excess?
Because you have to use it in excess. There's no other way to precipitate all your iodine out. Okay? Now, the student only has access to one Ki tablet and a balance that measures to 0.01 gram. Will the student be able to determine the mass of AGI produced to 3 sig figs?
Yeah.
1 Ki, 0.01. Can I have 3 sig figs? Zero 0.01. How many sig figs is that?
Yeah.
So you can only really go up to.
But what if you have like 1.01?
So if the masses can only be measured plus minus 0.1, and the dry AGI precipitate is going to be less than 1, right? If it wasn't less than 1, yeah, you could have 3 sig figs. But then you're going to only end up with 2 sig figs, not 3. Okay? So that's the first long question that you have. And it has a whole bunch of parts,
Oh, we did this one.
and up to 10 points.
We did the propanoic acid.
So the second one, continuing on to the second one, and I believe you did this already, right?
Yeah, I got 100 on this.
This is also a long essay. This has to do with acid, base, and pH, and titration, and Ka. So another full equilibrium one, and equilibrium is a big, big topic. So it's very likely that you'll have at least one of these long essays on equilibrium of sorts. Okay. So propanoic acid is carboxylic acid, and it gives you the pH. It gives you the equation, the net ionic, and then it's asking for Bronsted-Lowry conjugate base. How do you define Bronsted-Lowry conjugate base? How do you define them? Proton acceptor, proton donor, right? Which one is the donor, which one is the acceptor?
The acceptor is
The base, and the acid is the donor, right? So whatever is giving up its H, so looking at that equation, you see that the CH3, CH2, COH, which is propanoic acid, is giving up its hydrogen, right? So that's the acid, and water, H2O, is taking it up, so that's your base. Okay, so you either put the propanoic acid and the propanate as the acid-base pair, or the water and the hydronium ion. You can go either way, right? Either way, it's going to be the same pair. Now, how do you determine value of Ka? Ka is an equilibrium value, right? You're given pH, so if you're given pH, then you know your hydrogen ion concentration. Hydrogen and hydronium ion concentration are the same. And if you do a nice table, you're going to see that, when you do the minus x's and all that good stuff, you're going to see that your propanate and your hydronium ion concentrations are the same, right? So plug it into a Ka. The minus x doesn't matter in this case, right? Because of you're dealing with pretty small concentration of hydronium ion. You can use the 5% rule to double check that. But something like that, look at how many points they give you, right? They give you 2 points just for writing it out, right? Just for solving hydronium ion from pH, which is really just plugging in 10 to the negative 2.79 on your calculator and writing it out, is a point. Okay? 1 point for Ka, right? For plugging in and so on. Now, it says for each of the following statements, determine whether the statement is true or false. In each case, explain reasoning. So, the pH of the solution prepared by mixing 50 ml of the 0.2 propanoic acid with 50 ml of NaOH is 7. True or false?
False.
Why?
Because
What do you know about propanoic acid? Is it a strong acid or a weak acid? It's a weak acid. So if it's a weak acid, then you know that it has a strong base. And if you add a really strong base like NaOH to that,
yes.
you're not going to end up with a pH of 7. You're going to end up with pH of greater than 7. How about this statement? The pH of hydrochloric acid is the same as the pH of propanoic acid. Then the molar concentration of hydrochloric acid must be less than the molar concentration of propanoic acid. True. Why?
Because it's a strong acid.
Because it's a strong acid, so what does that mean?
It's going to
Completely
more than
ionize. Okay, so complete ionization is what is the difference there. Yeah, I'll post this. I can just email it to you guys.
You just look it up online.
Yeah, you can, but I can just email it. It's not big. So a student is given the task of determining concentration of this propanoic acid, and you have a 0.173 molar sodium hydroxide as your titrant, 25 milliliters of propanoic acid. After adding an appropriate indicator, the student titrates, and the end point is at 20.52. How do you determine the molarity of the propanoic acid given that info? What do you do? So you can go ahead and solve it with
You just divide it by something.
I'd rather have you do M1V1 equals M2V2, or molarity of the acid times volume of acid equals molarity of the base and times the volume of base. You can go about doing it the stoichiometry way, right? Converting your molarity times liters, you get your moles of propanoic acid, and then divide by the liters, or by the volume, or you can just plug into MAVA equals MBVB. I think it's a lot easier that way. Either one is going to get you just a point. So the student is asked to redesign the experiment, and the value for Ka for butanoic acid is 4.83. The student claims that a different indicator will be required to determine equivalence point based